So here's a great example of limiting reagent or reactant and calculating excess. So this one you actually are asked to calculate the grams of something. So to backtrack a little bit, the previous stoichiometry problems are just giving one thing, but if you're asked for limiting reactants and excess, you're given two things because two things are combining. You have to determine which one actually gets run out first. So first thing we have to do, first step, is to balance the reaction. And if we balance this one, if you want to pause it and try to balance this, I think we can, let's say, okay, let's put a 4 here and 4N, and then that's 12 hydrogens, so that's 6. And then how many oxygens do I have? I have 10, so 5. So let's double check, 4, 5, 4, 6. I think that looks good. So that's my balanced reaction. That's the first thing. The second step I need to do is change all this into moles. When in doubt, change into moles. So 3.5 grams of O2 times the division bar. So this is grams, moles of O2 at the top. 1 mole, and for O2, my molar mass, this is going to be 32 grams. So this is 3.5, let me punch this in, 3.5 divided by 32, I get 0.11 moles of O2. The next thing is 3.25 grams of NH3, and then do this, moles, NH3. So that's 1 mole NH3. This is what, 14 plus 3, which is 17. Canceled my grams. Oh, forgot to cancel my grams up here. This will give me 3.25 divided by 17, 0.19 moles of NH3. So right now I have the moles. So the next step I need to do, I'm going to set up my table. So the table is going to have first my O2 and also my NH3. Create my little grid. The first row is going to be what I'm given. This is what I have. And the second one is, well, what do I need with what I have? So this is what I need. So then I'm going to fill this in. So this is 0.11. This is for oxygen. 0.19 is for ammonia. Okay, so the next thing is to fill in the boxes for the need. I need to use stoichiometry. So basically, I just need to use, say, what I have, and I need to calculate how much, if I were to use that, how much of the other do I need? So this is what this step is about. It's a little confusing step. So 0.11 moles of O2 times division bar. This is all stoic steps, so this is all molar coefficients. So moles of O2 and then moles of NH3. I need to go back up to look at my molar coefficient of NH3 and O2. So it's 4 to 5 ratio. So this is 4 to 5 ratio. I think I got that right. So 4 to 5 ratio, that's right. So then my moles of O2 would cancel, moles of O2 would cancel. So I'm going to take 0.11 times 4 divided by 5. That gives me 0.088 moles of NH3. That means that if you're using 0.11 moles of O2, you're going to need 0.088 moles of NH3, so 0.088. Next one, I'm going to use 0.19 moles of NH3 times division bar, so I need to calculate the other one. So my moles of NH3 is going to be reversed from the top, so you can see instead of 4 to 5, I have 5 to 4. And then calculate this, cancel, so 0.19 times 5 divided by 4. My answer is 0.2375 moles of O2. So this is 0.2375. Okay, so at this point then now we can either use logic to make sense out of this, or we can subtract and see which one is positive or negative. So if we have 0.11, if we subtract this number, we're going to have a negative number, right? 0.11 is smaller than this, so you're going to have a negative number. You look at this one, 0.19, subtract that. Well, this has one more decimal place, so this is going to leave you a positive number. So because of that, this is my limiting reagent because it's negative, and this is my excess. And that's it. So we have determined that. If you want to use logic, you can say if you have 0.11 and you need 0.2375, do you have enough? And you don't have enough. So because you don't have enough, this amount will get used up first before this. And if you want to compare that to the other one, if you have 0.19 moles and you need 0.088, well, you have more than what you need. So that this is going to be your excessive one because you have more than enough. So we answered question 1. The question 2 is now how many grams of NO. So to look at that, now we have to look at NO on the other side of the equation. So once we have identified your limiting reactant, we have to use the moles of the limiting reactant because that's the one that determines how much products I have. So since O2 is my limiting, I'm going to use this one. This is the 0.11 because this is what I have. Not the what I need, it's what I have is the one I use. So the third question B, I'm going to use 0.11 moles of O2. I'm going to use stoichiometry because I need to calculate the moles of the other. So this is my moles of O2. And what am I asked for? I'm asked for my nitrogen monoxide, right? That's the question. NO, how many grams of NO are formed? So I'm using this limiting reagent, calculating the moles of the other ones. So the molar ratio is 4, I believe, 4 to 5. So you have 4 to 5. So I'm going to put 4 to 5 into my stoic ratio, so 4 to 5. And then cancel my moles of O2, giving me moles of NO. We're not done yet. Let's do 0.11 times 4 divided by 5. This gives me 0.088 moles of NO. Since the question is asking for grams, I need to use this 0.88 moles of NO, convert this into grams. So moles, grams, 1 mole. How many grams are there in NO? So this is going to be 14 plus 16. That's your molar mass. That gives me 30. Nice number. So that 0.88 or 0.088, this should be a 0 here, 0.088 times 30 gives me, oh, I think I did this one wrong, 0.088 times 30, oh, no, 2.64 grams of NO. That's what I have. So what basically we answered is that if you use this 3.5 grams of O2 reacted with 3.25 of NH3, I'm going to make 2.64 grams of NO. That's what we have just calculated. And then for C, we're calculating the excess. So how much is it do we have left over? So in order to calculate the excess, right, this is how much of the excess of the reactants remain. So now we have to look at from our table which one is the excessive one. Well, the excessive one is my NH3. How much of that actually remains? So we need to take what we have, and since that this is what it's going to be used, we're going to take 0.19, subtract this to 0.088. So I'm going to put the work here. So we're going to take 0.19, subtract that to 0.88. Well, I think it's 0.88, right? It's 0.88. Okay, remember these are all in moles, so this point like that. These are all in moles, so let's do that. 0.19 subtract 0.088. This is 0.102 moles of NH3. And if you want to calculate the grams left over, I just need to convert this back into the grams. So times division bar, moles, grams, molar mass of NH3 is 14 plus 3 because we have 3 hydrogens. That's 17 over 1. So then that gives me 1.734 grams of NH3. So what did we calculate here? This 1.734 grams, that's the leftover. So if you were to react these two things, my two initial reactants right here, if we were to react this and that, there's going to be something left over. Okay, NH3 is still left over. And how much is that? That's 1.734. So that's a limiting reagent with NSS calculations. Do a lot of practice because these questions are not easy. Make sure you know the steps, and hopefully this video has helped you. See you later.